Hi everyone, welcome back. Um, in this video, I'm going to be talking about HTTP. I'll show you what HTTP is, how it is, how Go programming language handles it, and I'll also show you how to write a basic web application in Go. And from there, we'll talk about REST APIs, what they are, and how you can go ahead creating one in Go. Okay, so I have an outline on how this video is going to progress. Of course, it's not going to be just this video. I might have to split it to multiple videos, but this is basically the things I want to talk about, and hopefully by the end of this lesson you will understand what HTTP is and how to write a basic web application. All right, let's get started. So in the notes here, I added two references. So the first link talks about HTTP, and the second one um, introduces you to REST APIs and what they are. So let's go ahead and open that up. So yeah, as you can see, what is HTTP? It stands for Hypertext Transfer Protocol. So the keyword here is that it's a protocol, and whenever you hear protocol, always think about this as some sort of standard that can be implemented by any program. All right, so for example, we know about the World Wide Web communication, which is www, and the internet as we know it. A lot of the internet as we know it communicates via HTTP, and HTTP is known to there's something we call request response cycles. So this is basically how HTTP works. A client sends a request to a server somewhere in the cloud, maybe somebody's computer or server, any servers anywhere, and then it receives a response from the server. Okay, so browsers, of course, is an example of a client, and they are often the most used clients that we know. But a client can be anything. It could be a program, it could be any device. Okay, so what are servers? Servers are basically computers that live anywhere. Maybe you could live on the cloud or wherever, data centers and stuff like that. All right. So I'm just glossing over through this. You can come here and actually read this thing in detail so that you will get whatever that confuses you, or shoot me any question if you have one. Okay, it says communication between clients and servers is done by requests and responses. Yeah, just like I said, a client sends a request to the server and the server sends back a response. And a classic example of this is, say you want to visit a website, you say google.com. This is a web address, and once you hit enter, your browser sends off this request to the Google server, and yeah, this is what gets returned. I think I should actually use something else. So let's say twitter.com, and we get a response. So basically what happened right now is the browser makes a request to this address. Okay, so there is a lot of details that actually happen in between the in between the transportation between the server and your computer. We have um, things like resolving DNS. We have things that your ISPs travels through some fiber optic cable to get to the server. The server processes the request and sends a response back to you. All those stuff, and yeah, so that is just a very rough idea of what HTTP is and how it works. Okay, so what else? Yeah, so the HTTP request cycle: browser requests an HTML, the server requests HTML, the browser can request CSS, return CSS, and so on. And there's just a lot. So many different kinds of data type can be transported between a server and the client. And as you can see here too, you can make a request for a data. You can tell the server I want XML or I want JSON. Just a lot of things can happen there, and with time you will get a hang of this. And okay, we also have HTTP request object. So this is JavaScript stuff, so I'm not going to really talk about it. Okay, we'll have a diagram down here. It says okay, browser, an event occurs, send HTTP request, it goes through the internet, the server receives it, processes the request, creates a response, send it back to the browser via the internet, and that's it. That's HTTP for you. All right. So now we're going to talk a little bit about this. Like that is as these videos progress, we'll see some parts of HTTP and how to exactly make these requests and how to configure responses from a server. So Go is the backend programming language, so it can be used to script a server. And unlike say HTML, you can't script a server with HTML. These days, of course, you can script a server with JavaScript because of Node.js. JavaScript actually started off as a client's language, so it only worked on the browser before the genius Ryan Dahl came up with the idea of Node.js, and all of a sudden we have really complex web applications running on JavaScript on the backend. Okay, so Go is a backend language, so which means it can only work on the server. It only works on the server, and basically our focus will be on using Go to program our servers to send the right response, process HTTP requests, send the right responses back to our clients. Okay. All right. So REST, on the other hand, is an architecture that is built on top of HTTP. Okay. So as you can see, it's representational state transfer. So it's some sort of a communication mechanism, right? And I mean, not in the sense of channels, of course, but it just creates a unified API that makes it easy for two programs or two machines to communicate. Okay, so in our case, it's going to be a client yet again and a server. Okay, in some sense. So as you can see down here, it says separation of client and server, and there's a lot of details right here. But REST is known to be stateless, which means it does not, it does not maintain session like when you are accessing a server through a browser. A browser creates a session and uses things like cookies to keep track of many things, and yeah, all those things are a lot of details. And sorry if I'm glossing over this, and it's a bit out of the scope of what of this course. So I would advise you, if any of this confuses you, please read these things up, and yeah, ask around, ask me if you have any question for me, and Google is your friend. Okay. So I'd also advise you to actually take your time and read through this particular article here. It's going to talk about HTTP verbs, and this is something that you will be seeing a lot. All right, as you progress in your software engineering career, you have a get, you have the post, put, and delete. I'll talk more about this as we proceed. Okay, and okay, we'll have headers too. I'll also talk a bit about headers when we start writing the code. So we'll have request paths, all of these things. Hopefully you're going to see it, and response code too. These are also some part of the HTTP standard, and they are predefined code that a client can interpret. So let's say you make a request to a server sends you back the status code saying 200. A browser knows what the 200 means, that it is okay, so it means everything worked well and it's success. If it sends a 400 status code, that means something went bad and it can be processed. So again, it's a protocol, some sort of a standard that helps makes it easy for machines to talk to each other and make it possible, not just easy, because if it wasn't like this, so many disconnects is going to exist on the internet, and thanks to HTTP, a lot of things are so much easier and faster. Okay, so yeah, so please make sure you go through this article just to get a sense of what it's talking about. Meanwhile, let's dive straight into code. Okay, so going to close this out. All right, so so Go comes with a package called Net. All right. Now inside net we have the HTTP package, and this HTTP package contains everything that we need to write HTTP based web applications. And the first thing that we're going to be implementing here is the HTTP server. So this will be a very simple HTTP server. So we have the listen and serve function. So we're going to pass in a port. So say port 8000, and normally we could use for a start, let's use the default servmux. Okay, so what this means is we're asking Go to create a HTTP server, right? And it's going to be listening for requests on port 8000, and we're asking it to use the default serve multiplexer. So what this is basically takes care of routing and stuff. Could actually replace this with nil, which will now prompt Go to use the same default handler. So we can also, let us go ahead and register a handle function, and this will be a path. So let's say this path is home, okay, and then we're going to pass in a function. So this function is what we call HTTP handler. So if you hover over this, you see where it says handler. Okay, so it's a function, some sort of an interface anyway, and the HTTP package expects you to define a method or a function like this, and what happens is when a request comes in to this home part, so this is a request part too, as we saw. So this home is a part. So when a request comes into this part, this function is going to be executed. Okay, so we're going to be using the FMT package to send a response back to the client that makes a request. Okay, so yes, so this in essence is a server. Okay, so like I said before, a server basically listens in for requests from clients, and then it processes their requests and sends them back a response, hence the name server. Yeah, so that's what servers do. Servers just serve, basically sit around and serve you with contents that you need or requests for. Okay, so let's go ahead and execute this code, and to do that I'm going to say go run cmd. And okay, right now as you can see, this doesn't exit, which it means that our server is now listening. And I'll actually make this in tell us that it's listening. So let me just quickly print something out. I'll say server listening on port 8000. Okay, so let's run this code. Oops, this is the wrong part of, yeah. So server listening on port 8000. So let's use a client, and the first client that we're going to be using, we are going to use a program to make a request to this server. So it's going to be curl and say http. So this is in local hosts. Okay, it's not accessible via the internet because we're not connecting our server to the internet just yet. So local hosts 8000. Okay, now I say we can add the request path, which is home. All right, and then I hit enter. As you can see, we get our response. So I can actually add a new line here so that we don't get that white percent sign that came out there. So if we run this, you can see this will have a response. Okay, so we can also make this request via the browser. Yeah, getting the same response. So that's basically what this is, a basic HTTP server. And yeah, we can go ahead and register even more handler functions just to get more things done. So we can now say here about, and can close this. I'll say about HTTP bingo. Oh, come on. All right, So go ahead and run this code, and then run it. You can also visit the about page and see, run this, everything works as expected. So that's that with this. So the next in line is routing. There's an interface that exists in the Go Standard library, which is basically called the handler. Okay, so this handler interface defines one function. Wait, let me try and locate it here. And every handler function, every handler type is expected to define a self HTTP function. So let's check that. I think this should be it, right? Yeah, this is the interface. Okay, so any interface that defines the self HTTP method, it's automatically a HTTP handler. Okay, so let's go ahead and implement that. So we're going to define a type, and we're going to call this type books. Okay, so it's going to be a map of okay, let's say string for now, string, and that's it. So go ahead and so let's go ahead and define books. So let's use a books, no need. Okay, and then I'll say self HTTP, and it's expected that we have a response writer and takes in a pointer to the request. Okay, so it's going to be, you notice that it is the same thing that we have here. That is what this function is going to take. So I'm going to do that, and we'll just simply go ahead and return fprintf. So we're passing it back here, and then we're going to say said welcome to books server. Okay, so we're going to pass in what we call, say, came via, call this %s, and right here we're going to have URL. So yeah, there's a URL property in this, and I'm just going to call the .string on it, so it will print out the URL that we use to visit to make this request. Okay, so we're going to save that, and going to go ahead and comment out all this up here. So I'm going to move these two into routing, right? Yeah. So let's go ahead and define our booking type, which of course is going to be a map. So say gonna say make map string and string. Yeah, I think this should work. So we can go ahead and pass this in here, save that, and there's a problem, does not implement. What am I missing? Okay, yeah, this is wrong. So just gonna say var bk gonna be books. Yeah, so let's take advantage of the zero value of our struct of our map. So go ahead and stop this, so we can recompile the program, and then start the program again, and our server has started. So we can actually also go ahead and make a request. As you can see, welcome to book server, you came via /about. Okay, so that works well. Let me just add this. Yeah. Oh, so we can compile a program, run this again. As you can see, it's working well. So we can say home /about, run this. As you can see, it's, so for now we have only one URL, and that's response. We have only one. We are handling every request that comes to this server from any path. So we are sending back the same response to it. So we could actually make this a bit different by using, maybe we could use a switch, and then we can say switch for r.url.string. okay, so can now say when it's about. All right, go ahead and print welcome to books server. You don't say welcome to book server. We can just say let me go ahead and duplicate this for now. Oops, that's not what I intended to do. This should fix it. Okay, so we can say welcome to book server, and for the about page you can say all about our library of books. So we can go ahead and go ahead and get rid of all this. So we're using the printf, and okay, could actually leave this there. Okay, come on. And then we can also add a default, this, which is going to be, now we're going to send a we're going to send we're going to be sending a default header. So it's gonna be dot right header. So hold on, don't panic about headers. I'm going to talk more about headers soon. So we're going to send 404. So 404 means that nothing was found, and I'm just going to write that back to the client, and that's it. Okay, so let's try running this code. I'm going to stop this and go ahead, recompile our program, and try visiting the home, and there we go. And then we'll see the about page, and we'll find it too, and we're going to try visiting a page that doesn't exist. So we know that we don't have any slash about slash home. If we hit that, you see nothing comes back because the header is just written back and it's a 404 error. Okay, so this is a very rough idea on how to add routing, although there are a lot more advanced routing applications that we already know. So we have the Mux router, sorry. Yeah, so the Mux router is one of the most famous routing libraries in Go. So you could come here, read documentation, and actually see how it is used. It takes care of a lot of details, so many things you don't have to handle, and it makes things a lot easier. And I don't know, maybe you might still use it during this video. It depends on how things actually go on. Okay, so yeah, let me actually now let me show you guys what headers are. I think if I say -h, okay, let me quickly Google that. So I'm trying to print out the headers of the response to the console, but okay, seems like I'm not getting it right. Let me check. Okay, this is long. I'm going to go ahead and pause this video and check this out, and I'll come back. All right, welcome back. So to do that, it's actually -i. All right, so let's see, -i. Yeah, as you can see, it says not found. Right, so this is a basic header, right? It's a basic header, and a header is I don't know. So it's like, say you made a request to you are trying to post a letter to a location, and you need to add details on the back of this letter. You're telling the person that receives this letter what to expect inside the letter, or any of those things, and that's what headers do. Okay, so as you can see, the server told us that it's a 404 not found. Okay, and as you can see, remember we wrote 404 here. If I go ahead and change this to say let's say 400, okay, it's a 400 status code. Remember the article I shared earlier, you can see all these error codes and see what they mean. If we try running this again, as you can see, changes to bad request. So you see date, today's date, and then we'll see content length, which means that no content was actually sent back to us. So we can actually also print the header for existing requests. As you can see, everything comes in, it says 200, okay, which means it was found. Dates, this is the length of the content, and we'll say content type, which says text plain. So some of these headers we are set by default by the Go programming language, and we can actually change our own header here. Maybe if you want to rewrite the content type, you can modify that and update that yourself. Okay, so that's that for headers, and the next is going to be how to load static files in Go, and hope I'm not missing something. All right, so one more thing. So let me go ahead and add something to our books. Okay, so I'm gonna say books, and we're gonna call this, I think we have a dot. It's a pen. Oh no. Can go ahead and say books. Silmaril, or okay, maybe I should just use the auto name. J.R.R. Tolkien, and I'm gonna assign this to Silmarillion. Okay, so hold on. Yeah, so that's a mistake. So we're going to save that, and that adds a book to our book server. And if we come up here, so let's go ahead and create another route. So this is going to be case, I'll call it, so let's see, nothing here, and then we can go ahead and check if we have. So we're going to first of all retrieve the item. So what I want to do is to pass a query parameter in our routes, which I'll show you how to do that, and then we're going to retrieve the value from the query parameter and access it from our books library. Okay, so I'm going to go ahead and pause this video and write this code out to save time. All right, so I went ahead and made some changes. So the first change I did was to change this to a literal, to an instance of books. So the other thing was I added a response for URL that does not exist, and I think I should update this too. So use the standard libraries constants. So this should be status not found. Okay, so yeah, that's it. So yeah, so basically what's happening here is we added an auto URL or an auto path. It's a path. So when someone visits or makes a request to this URL path and adds a query parameter called item, we're going to fetch this item, and then we're going to try and retrieve the item from the from our books library, which is the map here, and yeah, and then if it exists, we're going to return the name of the author of the book, and if it does not, we're going to say that we couldn't find the book. Okay, so actually I think let's just change some of these things. This shouldn't be an author, so this should be book. Okay, so we're expecting an author to be passed in the URL, not the book itself. All right, so let's start the server. gonna be run cmd, and let's say curl I say localhost server is, let's say, on port 8000, and we want to visit the author. Yeah, let's just call this book instead of author, so reduce the ambiguity with the code. So I'm going to start my server and then visit that. So if we send this, as you can see, it says book not found, because we didn't really pass the name of the author, and yeah, this doesn't look nice, but you get the idea. So let me add this here, and maybe okay, so let's fix this. Now let's add a query parameter. So the query parameter is basically parameters that named parameters that we can pass to our server. So we can go ahead and say item equal to, we know that we have JRR token, so we can type in the name token. When we hit that, it says no matches found for, okay, I think something is not right. Let me quickly add the HTTP protocol here, so my command line knows that I'm writing HTTP. So as you can see, it's skipping that for me, the special characters, by adding the backslash. That's what this backslash does. My command line does it on its own. So yeah, let's type in the name again, our token, and hit enter, and as you can see, URL not found. Okay, that is because we are checking for the whole URL, so we can want to check only for the paths. So to do that, we just use this path. All right, and try executing that again, and it still says the same thing. Okay, no, I need to restart my server and play this, and there we go. The book is the same Lyrian. All right, so let's pass in a name that doesn't exist. So we can go ahead and say N, hit enter, and you see book not found. And okay, looks like this guy is not stopping, so should actually put a return statement here, so this doesn't go on to execute the next line. So run this again, see book not found, gr token, and yeah. So yeah, that's it. That's basically what this is about. You can see this is a very ambiguous, and there are many ways to make this a lot easier, and can using things like the router can help arrange things. So yeah, I'm going to move on to the next lesson, which is going to be loading static files, which are CSS and JavaScript files, and also maybe images. So, and with that, I'm going to end this video and see you in the next one. Bye.